So let's talk about the scientific process. The same scientific process that we were talking about in grade school and high school and undergrad and postgrad. It's the same concept. It's just we're going to make sure we talk about it at the most advanced level to make sure that we can all be on the same page as to what's expected when doing the scientific process properly. First and foremost, before we get going too far into this, let's just keep in mind that the scientific process always originates in inquiry. It always originates in the idea of asking questions and trying to understand what we don't know. And also, a really important part of that scientific process is to make sure that we are always open to what those results are going to show us. We are not going in with a predetermined mindset as to what we are looking for. Good science lives and dies by our ability to put our bias away and make sure we focus on what the research, what the data, what the experiment is trying to show. If we don't do that, we can find ourselves in the cynicism trap, which cynicism is when you are focusing on trying to find data or answers that match a predetermined bias, something that you're hoping to see. And unfortunately, we do see a lot of cynicism these days, but not in good science. If science is done properly, it's a great way to put cynicism behind us, avoid any sort of conspiracy theories, and make sure that we are just focusing on what the data shows. So like I said, it is the same scientific method that you talked about in grade school. It is a methodology. It's a guide for how to properly complete the scientific process or to do the scientific process. But I always think of it as an idea that if you truly get good at the scientific method and how to do it, how to analyze the problem, how to do some research, find what you think is going to happen in your hypothesis, and then put it to the test, that this is something that goes far beyond any aspects of just a science classroom or a laboratory or even a research industry. It's a way of actually approaching problems in life. The same 5-step that you talked about in 3rd grade, observing a problem, forming a hypothesis of what you think is going to happen, creating an experiment, a controlled experiment from that hypothesis, collecting data from that experiment, and then referring that data back to that hypothesis to form a conclusion. That's the goal. That's what we've been trying to do. That's what science does when it's healthy science, right? You start with what you don't know. You find the research, you do the research, you dig for the research. You come up with a hypothesis, something that you can test and prove wrong, prove right, and then that's where the experiment originates. But realistically speaking, if we are actually talking about the scientific method as we actually know, the scientific method that is being utilized in laboratories across the globe, keep in mind that there are some more pieces to it than just what we saw in 3rd grade science standards, right? And so we're still going to be starting with observing a problem, right? That's never going to change. Observing the problem, what we don't know, what we're trying to find out. The next part is probably the part that a lot of us like to shy away from, right? The idea of doing our own research, trying to find the answer to that question, trying to see if that has already been answered, the research has been done. And if not, what is the experimentation that needs to be done to get us to better understand that problem or what we're trying to learn about. This one of those things that can take some time to do, but eventually the hope, the goal is that it gets us to creating a hypothesis, and that hypothesis needs to be testable, that we do. Problem is that finding that hypothesis is not always as easy as it sounds, right? I think sometimes we get in the bad habit in school that we kind of have this predetermined experiment, predetermined hypothesis, and we find ourselves in this trap of where we're just kind of walking through the steps of what we're expecting to find. But realistically, in a good scientific process, if we really don't know the answer, if we really do not know the problem, finding that actual testable thing, that thing that we think is the answer, it can require a huge amount of research, years of research, right? And I always think that if you can't do step number 3 here, if you can't form that hypothesis, it just simply means you need to do more research, right? Once you have that hypothesis, that thing that you're going to test, that thing that you think is the answer to the question, then keep in mind the next part of this problem is that we have to make sure we're able to create a good null hypothesis, which we'll talk about a little bit later on. Null hypothesis is essentially just going to test to see with what you are doing, your independent variable in the lab, if it actually has an effect on the end results. If it does, Fantastic. That's what we'll test in our experiment. The experiment should specifically be testing that one single variable we're trying to find in the hypothesis. If you can't do any of those things, if these don't work, it's pretty simple. We've just got to go back to that necessary research. That's the goal. Once we run the experiment, once we set it up, once we control it, once we know that we are testing just that one thing we are trying to find, that is where we're going to find ourselves doing the qualitative data and the quantitative data. We're collecting what we observe. We're collecting the numbers from the lab. We're maybe put them into data tables and graphs to make them easy to understand. And then we are going to move from the data to that conclusion, right? And that conclusion is going to always start with our hypothesis. We're going to review that hypothesis. We're going to talk about what we are expecting to see and whether the data supported what we actually saw when it was all said and done. The actual scientific process, it's the same 5 steps we talked about in grade school, except now we're just doing it in a method that is going to make sure that we end with results that are specific to our hypothesis.